Hello everyone. Myself Dr. Ashish Prakash, Assistant Professor in Department of Applied Science and Humanities in ABES Engineering College, Ghaziabad. Today we will discuss partial derivatives. First of all, definition of the partial derivative. Let z equals to fxy be a function of two independent variables x and y. Then the derivative of z with respect to x treating y as a constant is called partial derivative of z. That is with respect to x, and it is denoted by del z over del x or del f over del x or fx. This x is in subscript. Similarly, we can also find derivative with respect to y. The derivative of z with respect to y treating x as a constant is called partial derivative of z with respect to y, and it is also denoted by del z upon del y or del f upon del y, or you can say fy. Here this y is in subscript. Correct. Now we'll discuss higher order derivative, and notations for these second order derivatives are del z upon del x of del z upon del x, that is equals to del 2z upon del x square or fxx. These two x is in subscript. Similarly, we will go for partial differential with respect to y. Del upon del y of del z upon del y equals to del 2z upon del y square, or you can say fyy. Similarly, if we differentiate del z upon del y with respect to x again, that is del upon del x of del z upon del y will be denoted by del 2z by del x del y or fxy. And finally, if we differentiate del z upon del x with respect to partial derivative with respect to y, then it is denoted by del 2z by del x, del 2z by del y del x, or f y x. Correct. In general, these two, this one and this one, both are equal in general. Let us move. Now we are going to discuss some numerical of these partial derivatives. So very first question is, find the first order partial derivatives of u equals to tan inverse x square plus y square upon x plus y. So let us solve this problem. Partially differentiate u. Here u is the dependent variable because u is a function of x and y. So u is the dependent variable and x and y are the independent variable. So obviously we have to find first order derivative. First order means del u upon del x, and the second one will be del u upon del y. Correct? So for the first derivative del u by del x, partially differentiate u with respect to x. Obviously y will be constant, means treating y as a constant, correct? So let us differentiate. So del u upon del x equals to differential of tan inverse x is 1 upon 1 plus x square. So that obviously differential of tan inverse x square plus y square upon x plus y will be 1 upon 1 plus x square plus y square upon x plus y whole square. And now and now we have to differentiate this inside function again with respect to obviously x, treating y as a constant. So we will apply division rule, and for division rule, differential of x plus y whole square in the denominator, and now in numerator x plus y is same, but different partial derivative of x square plus y square, that is numerator with respect to x minus, obviously we are applying division rule, correct? So now numerator same, and partial derivative of denominator is del upon del x of x plus y, obviously with respect to x, correct? So this is the first order partial derivative of u with respect to x, and now we have to just solve this. Sorry. So let us take LCM. So after taking LCM, we will see this is x plus y whole square plus x square plus y square whole square, and in numerator it will go in numerator x plus y whole square, correct? And this function is x plus y whole square in numerator x plus y, and partial derivative of this x square with respect to x is 2x, and differential of y square with respect to x is partially 0 since y is a constant, correct, while differentiating with respect to x. Okay, so minus x square plus y square, and again partial derivative of x with respect to x is 1 plus partial derivative of y with respect to x is 0. So let us move and solve further. So this x plus y whole square is cancel out, and this is x into 2x is 2x square, correct? So del u over del x equals to x plus y whole square plus x plus y whole square plus x square plus y square whole square, x square plus y square whole square, and in numerator x plus x into 2x 2x square, 2x square, and then x into y is y into 2x is 2xy, 2xy. Now minus x square minus y square, minus x square minus y square. So result is 2x square minus x square is 2x square minus x square is x square plus 2xy minus y square upon x plus x square plus y square, x plus y whole square, sorry, x plus y whole square plus x square plus y square whole square. Similarly, as we know that this function u is symmetric with respect to x and y. It means if we replace x by y and y by x, then there will be no change. That's why this function u is symmetric. And for symmetrical function, we can directly differentiate u with respect to y, obviously now treating x as a constant. Correct. So just replace x by y and y by x. Then we will get y square plus 2x by 2xy minus x square upon x plus y whole square plus x square plus y square whole square. So let us solve one more problem. This is if z into x plus y equal to x square plus y square, then show that del z upon del x minus del z upon del y whole square will be equal to 4 into 1 minus del z upon del x minus del z upon del y. So let us prove. So obviously z equals to, here we can see, here we can see in the required result, we need del z upon del x and del z upon del y. Obviously z is the dependent variable and x and y are the independent variable. So first of all, we have to find value of z in terms of x and y. So from this result, z equals to obviously x square plus y square upon x plus y. So let us find del z upon del x and del z upon del y, and then we will put these two values in the left hand side and right hand side of the required result, and obviously both value will be same, so we can easily prove this result. Correct. So let us solve. Let us find del z upon del x. So obviously, if we differentiate z partially with respect to x and treating y as a constant, we will get del z upon del x equals to, here it will be division rule obviously. So x plus y whole square and x plus y same, and differential of numerator is 2x plus y square का differential 0 हो जाएगा, minus numerator same and differential of denominator is obviously differential of x is with respect to x 1 and differential of y is obviously 0. Correct. So what is the result? This is 2x square plus 2xy minus x square minus y square upon x plus y whole square. So result is sorry, x square plus 2xy minus y square upon x plus y whole square. Similarly, we can get easily del x del z upon del y. Just by replacing x by y and y by x is z is a symmetric function in terms of x and y. And so del z upon del y equals to y square plus 2xy minus x square upon x plus y whole square. Correct. Now the required result is for left hand side we have to subtract and then take whole square. So to find the left hand side, we have to subtract del z upon del x minus del z upon del y, and then we will take square. So obviously LCM is same, and so denominator is same basically, and so x plus y whole square. And if we subtract x square minus minus plus x square, it will be 2x square. Similarly, minus y square and minus y square again, so it will be minus 2y square, and 2xy and 2xy minus 2xy will be cancel out. And so if we take whole square of this result, we will get 4x x square minus y square whole square upon x plus y whole square. Correct. Whole square 2 to the 4. So obviously we are having left hand side equals to 4. Here it is an identity, x plus y, x minus y, x plus y, x minus y, and obviously whole square. And in denominator we are having x plus y whole 4. So this is the left hand side. Now we'll go for right hand side. So what is the right hand side? Right hand side is here 4 and 1 minus del z upon del x and minus del z upon del y. So we have to subtract both the derivatives from 1 and then multiply by 4. So let us start right hand side. For right hand side, we are having 4 into 1 minus del z upon del x minus del z upon del y. Just check. Yes, this is seen. Now, we have to subtract these two derivatives from 1. So 4 1 minus, what is del z upon del x? It is x square plus 2xy, x square plus 2xy minus y square upon x plus y whole square, x plus y whole square. And similarly we are having del z upon del y. It is y square plus 2xy minus x square upon x plus y whole square. So let us solve and check, is this same with left hand side? So it is 4. Just take LCM. So it will be x plus y whole square, and whole square is x square plus 2xy plus y square. And in the denominator, we are having x plus y whole square. Correct. And just take this minus inside, minus x square minus 2xy and minus minus plus y square. Similarly, for this bracket also, multiply by minus 1 minus y square minus 2xy and plus x square. Correct. So let us check. This x square has been cancelled out, and this 2xy is also cancelled out. This y square is also cancelled out, and no, this y square is cancelled out with this one, not this one. Okay, so we are having x square plus y square minus 2xy upon x plus y whole square, and there is a 4. And in the above side also, This x plus y whole square may be cancel out with this 2, and it will be 4x minus y whole square upon x plus y whole square for the left hand side. This was the left hand side, correct? And in right hand side also we are having 4 into, this is the identity, x minus y whole square upon x plus y whole square. So obviously we can see this left hand side is equals to right hand side, hence proof. These are some references, and thank you so much.